All right, now we're going to try balancing again, except this time we're going to use a list instead of pictures because it's a little bit more manageable. So to do this, you look at your equation, you make a list of every atom in it. So in this case, we have zinc and we have oxygen. And I'm just going to make spots to list the numbers of each atom on each side. So on the left side, I have 1 zinc and 2 oxygens. On the right, I have 1 zinc and 1 oxygen. So I look at this list, and I need the numbers to be the same on both sides. So then I say, okay, how do I change this? Well, I need more oxygen, so if I put a 2 out front, everything in the equation gets multiplied by 2. So that's going to change my zinc to 2, and it's going to change my oxygen to 2. So now my oxygens are balanced, but I got to fix the zinc, so I have to put a 2 in front of the zinc, giving me 2. So now this is balanced, I'm done. The oxygen gets left alone. So this works the same as the picture, but again, I didn't have to draw it all out. All right, so let's try another problem. All right, same thing. I look at this, I make a list of every atom. So there's K, there's Cl, and there's O. So I just write on each side. All right, I've got 1K, 1K, 1Cl, 1Cl, 3 O's, and 2 O's. So the only thing that needs to be balanced is the O. Again, it may be tempting, but I'm not allowed to just put a 3 there because that's changing what's being formed. I have to use numbers. So O is in groups of 3 on the left, 2 on the right. They're going to meet at 6. So that means I'm going to need 6 oxygens on the left. So a 2 here, 2 times 3 oxygens will get me 6 O's. But it's also going to double everything else. 2, 2. So I need 6 O's on the right, so I'll need a 3 there to get my 6. 3 times 2 is 6 O's. But I also have to fix my K's, so if I put a 2 in front of the KCl, 2 times 1K, 2 times 1, I get 2 of those. So again, if you add them all up, all the atoms are balanced as a result. So that's sort of the trick. Now, sometimes you have to be careful. So here I have C, H, and O. I'll make a list. So on the left side, I have 2 carbons, 4 hydrogens, and 2 oxygens. On the right side, I have 1 carbon, 2 hydrogens, and I have to be careful now because oxygen is in 2 places. I've got 2 here and 1 here for a total of 3. Anytime I change either one of those, I have to recount all my oxygens. In other words, let's balance the carbons. I'm going to put 2 here, so that's going to be 2 times 1, I have 2 carbons. But my oxygens have also changed now. I have 2 times 2 for 4 oxygens here, but I still have this one over here, so my new total is 5. I have to recount both of them each time. Hydrogens, I have 4 on the left, so I'm going to need 4 over on the right as well, so I'll put a 2 in front of the water. So it's going to give me 4 hydrogens, but I'm going to change my oxygens. Now I have 2 oxygens here, so I have 4 from the CO2 plus 2 from the H2O for a total of 6. And then, okay, to finish the oxygen, I need a 3 in front of the O2 for a total of 6. Typically, oxygen is usually one you want to balance last because it has a tendency to be in multiple places. So when in doubt, use that one last. All right, next equation. This one's getting a little more complicated. I've got 4 atoms. I've got Fe, got Cl, Na, and P. So again, I'll just make my lists. I've got 1 Fe, 2 Cls, 3 Nas, 1 P. On the right, I've got 3 Fes, 1 Cl, 1 Na, 2 P. And again, it doesn't really matter where you start. After doing a lot of these, you'll get an idea. But in this case, I'm going to start with iron. I have 3 on the right. I have 1 on the left, so I'll need a 3. It's going to give me 3 irons, and 3 times 2 is 6 chlorines. Okay, so that's taken care of. So now I got to try something else. Maybe I want to do my NAs. So I've got 3 NAs on the left. If I put a 3 here, oh, that'll take care of my NAs. Great. It's going to bump up my Cls as well. So I have most things balanced at the point. I need more chlorines, though, and I also need more phosphorus on the left. So let's say I take care of the phosphorus on the left. If I put a 2 here, 2 times 3 is 6 NAs. 2 times 1 is 2 phosphorus. So I just messed up my Na again. That's okay. This is a trial and error process. You can change the numbers. So I have 6 NAs on the left. 2 times 3 is 6. So I need 6 on the right. So I can get rid of this 3 and start over. If I need 6 NAs on the right, I'm going to end up needing a 6 here. So I will put a 6 there. That's going to put my Na back to a 6, my Cl to a 6. So you can keep changing the numbers until it works. If the numbers ever get really, really large, then you need to really reconsider and maybe start over. So that's that. Another thing to keep in mind is it's possible to balance this multiple ways. You always want to make sure your numbers are reduced. So in other words, another answer that would work is 6, 4, 2, and 12. But I want to reduce it, just like you have a fraction of 2/4 reduces to 1/2. If you have all the numbers that are can be reduced, you want to reduce them. All right, so let's just move on to a couple more. I'll show you a few tricks. This is one that you would have a very, very difficult time balancing if you were to write out all the atoms. So one thing you do is when you come across ionic compounds, especially with polyatomic ions, you want to treat them as if they were just their own atom. So in other words, in this case, I have Sr. I also have OH. I'm going to call OH. I'm going to print OH as just like a regular atom, nothing else. Same thing here with NH4. It's just NH4. And the same thing with CO3. These are all polyatomic ions, but if I did this with separate O's and H's, I would have a very difficult time balancing this. So I'll make my lists, and let's see. So I have one Sr on the left. I have 2 OHs, and I also have 2 NH4s. Now, a common mistake people make is they look and they see the 4 and the 2, and they think they have 8 NH4s or 8 NHs. Remember, this 4 is part of NH4. For all practical purposes, it's not even a number. Consider it a letter. So there are 2 of this entire group, and that's what we want to keep track of. As far as CO3, there are not 3 COs or 3 CO3s. This represents 1 CO3. The 3 is part of that group. We don't even really think of it as a number. On the right, I've got 1 Sr, I have 1 OH, I've got 1 NH4, and I've got 1 CO3. So just be very careful here. This one's actually not too difficult to balance once we make this list. You'll see the only thing we have to change is put a 2 here to give myself 2 OHs and 2 NH4s. And that's it. This thing is balanced. It's done. And again, just make sure it's reduced. If you were playing around, it's possible you could have gotten the answer 2, 2, 2, 4. While this is technically balanced, if you have that, it's not the proper way to do it. You're always supposed to reduce. So it'd be 2 here, 1, 1, 1. All right, and lastly, that's it. So that's how you balance. I have one more video I'm going to post with a few shortcuts and tricks that you might want to watch to help you with this process. But otherwise, you should be armed with enough information to get you through these types of problems. So anyway, that's it. Until next time, I am Derek Genova. Have a delightful day.